Good morning, grade nines. Hope you are well. I'm still your host for grade 9 natural sciences. My name is Polisani Mbata, and you can still find me on Twitter at MbataX, on Instagram at XKIM. Those are my social media handles. Today, what we will be looking at specifically today is the following. I hope you did your homework as I gave you the homework yesterday so that we can easily do corrections just now. So yesterday we were doing the reactions, then today we are still continuing the section or the our second term work is matter and materials. By the end of this lesson, you will learn the following: reactions of acids with metal carbonates. We'll also know what are metal carbonates. We'll also know the application of acid-base reactions. So that will be on our daily basis. Then we'll also look at reactions
Karen,
of
don't tell me.
acids with metals. And then we'll also learn how to test for hydrogen gas. So our homework, let us look at number 1. Yesterday I gave you this homework and then I said sodium hydroxide and nitric acid. So you had to work out the reaction of this sodium hydroxide and nitric acid. So that was our learning outcome for yesterday. So the homework was actually made to check you if you understand. So I remember yesterday I told you, or we discussed that you need to first, if you are given a word equation, you change it into symbol equation. So here you were given the word equation, but you were not given the product. When sodium hydroxide reacting with nitric acid, what do we get? But we were told that when a hydroxide reacts with acid, what do we get? We get salt and water. Are we clear on that one, grade 9? So please check your homework now. We are doing corrections. First thing, you were to turn this word equation into a symbol equation. So sodium hydroxide, there we go. That is sodium hydroxide. They said it is reacting with nitric acid. We all know nitric acid is HNO3. That's our nitric acid. What do we get when sodium hydroxide is reacting with nitric acid? We get sodium nitrate, which is salt, right? Sodium nitrate, it's a salt. Obviously, what else do we get is water, because a hydroxide is reacting with an acid, so we get a salt and water. Our type of salt that we get when sodium hydroxide is reacting with nitric acid is a sodium nitrate. That's a type of salt we get. Did you get something like this, grade 9s? Did you get something like this, grade 9s? Then we will now have to check if our equation is balancing. Is our equation balancing, grade 9s? Yes, it is indeed. We've got one sodium molecule on the left. We've got one sodium molecule on the right. We've got 2 hydrogens on the left. We've got 2 hydrogens on the right. We've got this nitrate, NO3, and then we've got NO3 this side. So our equation is balanced. You can give yourself a mark. Then now we look at the following reaction that you were given. You were given calcium hydroxide and hydrochloric acid. You were given calcium hydrochloride. Let us look at calcium hydrochloride. The same thing we already know. Calcium hydrochloride reacts with hydrochloric acid. What do we get? Calcium hydrochloride reacts with hydrochloric acid. What do we get when calcium hydrochloride is reacting with hydrochloric acid? So we're gonna get a salt and water. So what type of salt are we getting there, grade 9s? It's calcium chloride. Calcium chloride. Are you aware? Yes. And what? In water. So there we go. We have calcium chloride, which is a salt that is formed, and we're getting calcium chloride, and then we're getting water after that salt. Then now what do? We check, is the equation balanced? Is the equation balanced, grade 9? Nope, it is not balanced. Let us try and balance it now. So we have a calcium on the right, our calcium hydroxide, calcium hydroxide. Then now we are trying to balance our equation, grade 9. It is important to make sure that you balance your equation at all times, grade 9. So when we're balancing the equation, we're saying the reactants should equal the product's atoms. The atoms should be equal. So I want us to balance it together so that you can now know how to balance the equation. We've been doing that the whole week. So there we go. Is this equation balanced? No, it's not balanced. So we need to put in the coefficients to balance this equation so that we know how to. But first, you need to calculate. You need to calculate your atoms, your atom molecules one by one. Are we clear? So now we will say, okay, we have 2 hydrogen atoms on the left, and we've got 1 oxygen. This side, we've got two oxygens and 2 hydrogens plus 1 hydrogen, which is 3 hydrogens on the left. So how do we do this? Are we gonna say, let us put 2 coefficient here, and let us continue to put the coefficient 2 here. And then, is our equation balanced? Yes, it is balanced. The chlorine, this side are 2, this side are 2. The hydrogens, this side are 4, and then this side are 4. 2 here and 2 here, that's 4. So the equation is balanced. Are we clear, grade 9s? Are we clear, grade 9s? Thank you very much. Let us move to the next question now.
Yes.
We move to the next question. You were given calcium hydroxide. You were given calcium hydroxide. Oh, and sulfuric acid. You were given calcium. No, you were not given calcium. You were given magnesium hydroxide and sulfuric acid. You were given magnesium hydroxide and sulfuric acid. So it's magnesium hydroxide. Magnesium hydroxide. Are we clear? There we go. It's reacting with hydrochloric acid. And what do we get? There we are getting, what type of salts are we getting? It's magnesium chloride, isn't it? No, we're not getting magnesium chloride, but we're getting magnesium sulfate. We are getting a magnesium sulfate. What am I doing, grade 9s? Why you are not correcting me? It's not reacting with magnesium. It's not, magnesium hydroxide is reacting with reacting with sulfuric acid, which is H2SO4, and then it is going to give us magnesium sulfate. Are we clear on that one? Magnesium sulfate and water. And water. There we go. Did someone get something like mine? I hope so. We need to balance it now. Let us calculate grade 9s. Let us calculate if we are getting the same thing from the product equals the reactants. We need to check that one out. So now you already know that we count each by each. We are counting one by one. We need to count one by one if they are all equal. So the first one, you can see it is not balancing. Look at your oxygens. Look at your oxygens. On the left, we've got, I always recommend that when you are to balance the equation, you first have to start with oxygens. Let us calculate the oxygens on the left. You've got 1, 2, 3. So it's 4. You've got 6 on the left. You've got 6 on the left. And then if we've got 6 on the left, how many do we have on the right? We have 5. So automatically the oxygens are not balancing. We already need to work on that one. Are we clear, grade 9s? So how are we going to balance it? So we are going to say, okay, if we put a coefficient 2 here, then how many do we have? Then we also have to say, okay, then now everything is equal. Are we clear, grade 9s? We've got 4 on the right. We've got 4 on the left hydrogen atom. We've got 6 oxygen atoms on the left and 6 oxygen atoms on the right. So magnesium, and SO4. So we are good to go. We have balanced our equation. Let us look at potassium hydroxide reacting with hydrochloric acid. So potassium hydroxide, when it is reacting with hydrochloric acid, potassium hydroxide is reacting with hydrochloric acid. What do we get? We get potassium chloride, and we're getting potassium chloride and water. Remember, we get salt and water when an acid is reacting with when a hydroxide is reacting with an acid, we're getting the salt and water depending on the reactants. So let us look at this one. Is this one balanced, grade 9? Is this equation balanced? Yes, it is balanced, grade 9. Let us look again. How many hydrogen molecules do we have on the left? 1, 2. So we have 2. On the right, we've got 2. We've got 1 oxygen, we've got 1 oxygen. And then we've got chlorine molecule, chlorine. So the equation is balanced. Let us continue to the last one, grade 9, so that we can move to our today's lesson. We get aluminium hydroxide. Then when you're looking at aluminium hydroxide, you are going to see how we balance this one. Remember the symbols we get them from? We get the symbols from the periodic table, grade 9s. I'm not coming up with these things. We take them from the periodic table. So it is reacting with hydrochloric acid. It is reacting with hydrochloric acid. What do we get? From this reaction, we get aluminum chloride, which is a salt, aluminum chloride, which is a salt, and water. We always get water if a hydroxide is reacting with acid. So you can already see that we are not balancing. So we need to balance by adding coefficients to make sure everything balances, grade 9. We need to add a coefficient to make sure that everything balances. You calculate each element or each molecule on the left and on the right. They need to be equal. So already you can see that they are not equal. So what we're going to do is we are going to add those coefficients. So how are we going to do this? Because of here we've got 3 hydrogens and then it's 4. On the right we have 2. So now we need to make sure that we add the bigger number here, which is 3. And then we have 6 now hydrogen atoms and 3 oxygens. So the oxygens and the hydrogens are now balancing, right? Let us see what else can we balance now. We can see that, oh, they are not, the chlorine now is not balancing. There are 3 this side, there were 2. So we need to put a 3 there. And then now everything is balanced. Do you see, grade 9s, what we did there? Do you see what we did there? Thank you very much, grade
Yes,
9.
sir.
Thank you very much, grade 9s. Thank you very much. Let us move on to our second correction. This one is very easy, so we're not going to waste time. We said that this was homework number 2 from yesterday. We said to yesterday or the other day, metal and when metal is reacting with oxygen, we get metal oxide. It's metal oxide. Remember, this is some sort of revision strategy that I use with my learners in my school, and because if we stay long not doing something, you will fail. So now, if non-metal is reacting with what to get a metal oxide, if it's reacting with oxygen, anything that reacts with any metal reacting with oxygen, we get a metal oxide. If a non-metal is reacting with oxygen, we also get non-metal oxide. Are we clear on that one? So when a metal carbonate reacts with acid, we get salt, water, and remember we did this yesterday. And a metal carbonate, we did this yesterday. When it's reacting with acid, we get salt, water, and carbon dioxide. We get carbon dioxide. Remember from yesterday's notes? Yes, some sort of a quiz, grade 9. This is not, it's not something new. It's something we've done together. So I want you to see that you are following, grade 9. So I don't teach you to forget. So they say carbon burns in oxygen. If carbon burns in oxygen, it simply means there's a reaction between carbon and oxygen. Carbon burns in oxygen. Oxygen is a diatomic molecule. We represent it as O2. Then we're getting what? We're getting CO2, which is a carbon dioxide. So when you're getting a carbon dioxide, look at that equation, grade 9. Is that equation balanced? Yes, it is balanced. Look at it, grade 9. Again, yes, when carbon is reacting with oxygen, we always get a balanced equation. We've got O2, O2, C, C. Therefore, it is balanced. The reactants equals them. The reactants equals the product, so it's fine. We are good to go. And then we've got magnesium, which burns in oxygen as well. Magnesium burns in oxygen. So magnesium reacts with oxygen. What do we get? We get magnesium oxide. It's a metal reacting with oxygen, so we always get an oxide. So it's a magnesium oxide. So you can see already that this is not balancing. It is not balancing. So we'll have to add coefficients to actually balance it. So we'll say, because we've got 2 oxygens on this side and this side we have 1, so we can put 2 there. So we have 2 oxygens and 2, but now we have 2 magnesiums as well, 1 magnesium. So what are we going to do this side? We're going to put a 2 there, and then our equation is balanced. Are we clear, grade 9s? Thank you very much. Sulfur also is burning in oxygen. Sulfur is a metal. So we say, so we are going to, is sulfur a metal? Let us check on our periodic tables, grade 9. Sulfur is not a metal, but it is a non-metal. Sulfur is a non-metal. So now what we're going to do, the same reaction, the presentation, sulfur reacts with oxygen to give us a non-metal oxide, which is a sulfur oxide. Are we clear? A sulfur oxide, which is non-metal, and then we're getting sulfur oxide. Then how are we going to do it? We're going to put a coefficient 2 here because of the oxygens already. There are 2 on the left and there must be 2 on the right, and then our sulfur we need to put a coefficient 2 there, and then we have a balanced equation. We have a balanced equation. I want us to continue to our today's lesson, grade 9. It is important that we do our lesson for today without any waste of time. I'm going to move a bit fast, grade 9s. Please bear with me. These notes will be available on YouTube, and they will also be available on our site, www.africateamcakes.co.za. Then you click Natural Sciences, and then you open the folder of PowerPoints there. Then you will get your notes. Then if you don't find that one, it's difficult for you, please go on YouTube and find today's video. You can pause it as many times as you want as you are working through with me during your own time. Then now, today's lesson is reactions of acid with metal carbonates. What are metal carbonates, grade 9? Metal carbonates are compounds that consist of a metal and a carbonate. So you've got a metal and a carbonate. Our metal there is going to be calcium, and our carbonate is CO3. Then a carbonate ions consist of a carbon atom and 3 oxygen atoms bonded together. So when we've got a carbon atom and oxygen, 3 oxygen atoms bonded together, we call that a carbonate. We call that a carbonate, grade 9. So they say atoms are bonded together, so they now become one. It becomes one, and then we call that group a carbonate. CO3 is known as a carbonate. The ion carries a negative electric charge, which is 2. Then we have this group. We call this group a carbonate. Are we clear, grade 9s? Are we clear, grade 9s? So calcium carbonate, grade 9s, what do you think is an example of calcium carbonate? So the blackboard chalk was traditionally made of calcium carbonate. Today, most chalk is made of calcium sulfate, are also called calcium carbonate, and calcium sulfate are examples of the chalk that we use in classrooms. You know, when you are not in a 21st century where you use whiteboards, when you're still using those green chalk balls and then you're using a chalk, you must know that you're using a calcium sulfate or a calcium carbonate. It depends on the material that is used in your chalk. Isn't it interesting how how relevant is chemistry in our day-to-day lives? Then metal carbonates are bases. They have the ability to make acid less acidic. So a metal carbonate is a base, and you all know by now that bases have the ability to make actually acidic substances to be less acidic. So they say most carbonates are not soluble in water, or they are only soluble partially. So we say they are partially soluble. When an acid reacts with a metal carbonate, the products are salt, water, and carbon dioxide gas. That's our form. Grade 9s, don't forget, when a hydroxide is reacting with acid, we get a salt and water. When a metal carbonate is reacting with acid, we get 3 products. We get salt, we get water, we get carbon dioxide. Are we clear, grade 9s? So you must know, when you see something with CO3, you know it's a carbonate. Magnesium carbonate or sulfur carbonate or whatever carbonate, you say, okay, maybe let's make an example with calcium carbonate. Then you already know whatever is going to react with that carbonate, you are going to have 3 products: a salt, a water, and carbon dioxide. The salt is always determined by the type of reaction that is happening with that type of acid. Are we clear, grade 9s? Are we clear, grade 9s? Thank you. The type of salt that forms depends on the acid and metal carbonate that are used in the reaction. There is a general word equation. Metal carbonates react with acid to give us salt, water, and carbon dioxide. Write that down, grade 9. General weight equation for carbonates. Metal carbonate reacts with acid to give us salt, water, and carbon dioxide. Are we clear, grade 9? Are you following, grade 9? Thank you very much. I hope you are following. This is very serious, because if you are going to continue with your chemistry in grade 10, these are the most important fundamentals.
Yes, sir.
Let us look at the examples. Word equation. Calcium carbonate reacts with hydrochloric acid to give us calcium chloride, which is a salt, plus water and carbon dioxide. At this stage, grade 9, you already know that when you see CO3, that's a carbonate, and you know that this is we're having a problem with the network, grade 9, but you can write this equation first. Am I kicked out? No, I'm coming back. Grade 9. I don't know what's happening. I'm gonna try close this one. Grade 9. Then we come back here. We have that. I'm back. Let us look at this one. CO3. This CO3, grade 9, already tells you that you're gonna have 3 products, and it's going to be a salt, water, and carbon dioxide. Already, when you see CO3 in the reactants, you already know that your products will be 3. It will be a salt, it will also be water, it will be also carbon dioxide. Hope you are taking notes, grade 9, because now I'm balancing it for you. You see, how did we balance it? Is it balanced? Nope, it is not balanced. Look at it, grade 9. So, yes.
Please go back. We are just going too fast. Please go back to general weight equation.
Okay. General weight equation. There we are. This one. Or must I go a bit back? This one. Or must I go back?
No.
Further back?
Yes.
Okay, where we were. I know I might be moving.
Yeah, this one.
Yes. So I will explain this one again. So I was saying to you, grade 9, when a metal carbonate, when you see a carbonate is represented by 1 atom molecule bonded together with 3 oxygen molecules, right? So we call that group a metal carbonate. So there will be a metal, for example, calcium carbonate. So it's going to be CaCO3. That's the calcium carbonate. When it's reacting with whatever acid, your product will always be salt, water, and carbon dioxide. Are we clear, grade 9?
Yes.
Then let us move on. Then I'm giving you an example now, grade 9. Calcium carbonate, which is a what? It's a metal carbonate. A metal carbonate. Calcium is metal from your periodic table, grade 9. Calcium, yes, it is a Ca, it is a metal. Then calcium carbonate, how do you know it's a carbonate? Because you've got this CO3 here, and then you already know that hydrochloric acid, it is an acid. Your product is salt. What type of salt do we have here? It's calcium chloride. And then we have water, and then we have calcium. We've got calcium, carbon dioxide. Then we have 3 products. We are good to go. Then we need to balance it. Is it balancing? No, it is not balancing. This side we have 1 chlorine molecule. This time we have 2. Then we put a 2 coefficient 2 there, and then everything automatically balance. You can count 1 by 1, as I've been saying. On the left, you've got 1 calcium. On the right, you've got 1 calcium. You've got CO3, and then you've got how many CO3s here? Yes, we do get CO3. We've got 1 calcium here, and then we've got 1 here. That adds up to be 3. You've got 2 oxygen and 1 here. That adds up to be 3. There we go. CO3 is 3 this side, and this time we're gonna have 3. Then we have 2 hydrogens on the left, on the right, I'm sorry, and then we have 2 on the right, on the left. Then everything is balancing, grade 9s. Are we clear?
Yes.
Let us look at another example, grade 9. I want everyone to be clear. There we go. Magnesium carbonate. Magnesium is a metal. So we have magnesium, and then our product is magnesium sulfate, which is a salt, plus water and plus carbon dioxide. Fortunately enough, our equation, symbol equation, remember I told you that WE stands for weight equation, SE stands for symbol equation. Then for us to balance our symbol equation at all times, we need to, for us to balance the equation, we need to always convert it into a symbol equation so that it becomes easy for us to work with. Are we clear, grade 9s? Then I'm not moving too fast, I hope. You can see that the reactants equals the product. The reactants equals the product. So you can see this equation is balanced, grade 9. This equation is balanced. The equation is balanced. I'm going to move on, grade 9s, so that we save time. Let us look at sodium carbonate when it's reacting with nitric acid, and then our product is sodium nitrate and water and carbon dioxide. So I want you to copy this one down and see how I balanced it. It is very important for you to know how to balance the equations, and it is also important for you to know the types of reactions and the types of products that we get. It is very, very important. So grade 9s, please go to my Instagram or Twitter, and before 2 p.m. today, to type anything that you would like us to revise tomorrow. Tomorrow, the lesson will be conducted by everyone's input today. You just type in anything that you want me to actually rectify. I know some of you were not with us in Teams last week when we started with chemistry. So if you've got any questions that or any topic that you did not understand under chemistry, please go to my Instagram or Twitter and direct message me to say, Mr. Mbata, tomorrow please look at the following. Are we clear? Tomorrow, just say, Mr. Mbata, look at the following. Tomorrow, the lesson will be obviously conducted by you guys.
Sir.
Yes?
What's your Instagram?
At XKIM. At XKIM. I'm going to show you to you just now by the end of this lesson.
Yes.
So now, how do we test for carbon dioxide, grade 9s? So this one, it's for those who are actually interested in chemistry next year. You will do this in detail in your respective schools. But how do we test it? You already know the chemical formula for carbon dioxide gas, which is CO2, when we have 1 carbon atom and 2 oxygen atoms. Then this is carbon dioxide. And then if we've got 1 carbon atom and 3 oxygen atoms, that is a carbonate. don't actually confuse the two. We've got carbon dioxide and a carbonate. So a carbonate has 3 oxygen atoms. So carbon dioxide has no color or smell. I know most of you think carbon dioxide has a smell. I will explain as we go on why we say it doesn't have a smell. It depends on what is it that is reacting with carbon dioxide to give us that smell. That is obviously going to be a type of smell. When we're looking at the application just now, you will see why they say it doesn't have a smell. If you want to know whether carbon dioxide gas was formed in a reaction, you first need to trap it. So in lime water is a solution of calcium hydroxide. If you filter the lime water so that it is clear, you can use it to test carbon dioxide. So if there is carbon dioxide reacts with clear lime water, it will turn milky. In grade 10, you will learn why this happens. This is the extra information that Mr. Mbata gives you. Then the bicarbonate of soda, grade 9. Bicarbonate of soda, you know what do we call it? I'm going to use it tomorrow after the lesson tomorrow. The bicarbonate of soda, we call it a baking powder. We call it a baking powder. So there's a formula for baking powder. Is used for baking when it is heated and reacts with other ingredients. Carbon dioxide gas that will smell with like vanilla or whatever you put in your dough is released. This makes the bread or cake to rise. So now you see why I said CO2 doesn't have a smell. It depends on what it is reacting with. The CO2 that comes from the cake smells so nice, but the CO2 that comes from your body, which is fat, doesn't smell so well. So yes, grade 9. So CO2 depends on the reaction, then we get a smell. But CO2 doesn't have a smell. Then what else do we know about our bases is that excess stomach acid causes indigestion and heartburn. Antacids are used to neutralize excess stomach acid. Different antacids contain different bases. For example, calcium carbonate. So calcium carbonate, you've got magnesium carbonate. You've got magnesium carbonate. Those, they all assist in indigestion. If you have a heartburn and you take this, you will be helped. These are the useful bases that we can use to fight. Why are they like aluminum hydroxide? Remember, we said hydroxides have an ability to actually make the acidic stuff less acidic. We also said the same thing about carbonates. We said the carbonates, they actually make the acidic stuff to be less acidic. So we all know that in our stomachs, we've got acid. That's why you're gonna have a heartburn or indigestion. Then you need these carbonates to actually lessen the acid in your stomachs, and then you can be good to go. This is so practical, grade 9s. The chemistry is very practical. Let us look at when an insect bites you. It injects a small amount of a chemical into your skin. This is why it stings. For example, when a bee injects an acid, the bee sting can be neutralized using a base such as bicarbonate of soda or a weak acid such as a vinegar. Another base that we use every day, grade 9s, it will be your toothpaste. Density, you already did this in grade 8 and grade 7. Density is amount of mass in a given volume of a material. When a when a metal reacts with an acid, the products forms are salt and hydrogen gas. So there we go. This is another one. When an acid, so a general word equation, when a metal reacts with acid, your product will be a salt and hydrogen gas. Are we clear? So whatever reacts a metal, you go on your periodic table and then you'll see. Let us look at the example. There we go. Magnesium reacts with hydrochloric acid to give us magnesium chloride and hydrogen. There is a simple equation. Magnesium reacts with hydrochloric acid to give us magnesium chloride and hydrogen. We get salt and hydrogen. So we're getting a salt and a gas this time around. When we said when the previous one, when a carbonate reacts with an acid, what do we get? We get three. We get a salt, water, and carbon dioxide. But when a metal is reacting with an acid, we're getting two. We're getting a salt and a gas. We're getting a salt and a gas.
Yes.
Are we clear, grade 9?
Yes.
And this will help you to actually understand. Remember, I told you, I said, when you make a periodic table your friend, you will not fail. You will not fail chemistry because you will understand. The minute you see zinc, oh, SO4, oh, that's a sulfuric acid, so it's an acid. So now what you're going to do, you're going to say, oh, zinc is a metal, H2SO4 it's an acid. What type of an acid? Is a sulfuric acid. So now what do I need to get as products? I need to get a salt. Oh, it's a zinc sulfate and what? And a gas. That's it. That's how we're going to work it, grade 9. Are we clear? There we go. Copper. Oh, copper is a metal as well. Copper is a metal. What's going to happen now? If you're looking at this, you're going to get copper nitrate and hydrogen. You already know this is your these are your products, and then we balance it. Remember, grade 9s, please, for the life of me, I beg you to always balance your equations. Always, all the time. Make sure after you've converted from word equation to symbol equation, then you need to make sure that you balance, you count. You need to count, grade 9s, so that you get full marks. Are we clear? Look at this one. When you're giving a word equation, I'll give you a mark for converting a word equation into a symbol equation, and you can also get another mark for balancing the equation. So don't waste marks. We can still also test for hydrogen, grade 9s. When we're testing for hydrogen, hydrogen is a diatomic element. This means that hydrogen, we did the diatomic elements, grade 9s. We did them like more than any other thing. So you can follow these steps when you're testing for hydrogen. So this means that hydrogen gas is not made up of a single atoms, but of molecules. Each molecule consists of 2 hydrogen atoms bonded together. The formula for hydrogen gas is H2. I'm moving fast because we have got less than 5 minutes left. So hydrogen has a lower density than air. So that means hydrogen is lighter than O2. It has no color or smell. It reacts violently with oxygen. The reaction produces water. Or hydrogen reacts with oxygen to give us H2O, which is water, grade 9. Did you know that the reaction between hydrogen and oxygen gives off a lot of energy? So what type of reaction is this? Is exothermic reaction. Remember, we did exothermic and endothermic reactions, grade 9. Remember that? It only produces water, and as a product, this quality makes hydrogen useful as fuel. It was used to launch space shuttle. But what is happening at the moment? Scientists are also investigating the possibility of using hydrogen as an alternative fuel source for cars and airplanes, so that we actually protect our ozone layer. Grade 9, here's your homework. Please write it fast before I log off. There is your homework chemistry practice test. Give the correct scientific term for each of the following descriptions. A, an arrangement of elements in an organized pattern. What do we call that? A metal with 25 protons. What in its nucleus? What is that? In its nucleus, examples include potassium, iron, and carbon. What are those? Sodium, potassium, iron, and carbon. What do we call those? The classification of iron A non-metal found in all living things. What do we call that non-metal? Number 2, use the periodic table to answer the following questions. Name the noble gas in the period 2. What element has 86 protons in the nucleus? Name the element with the symbol Sn. Describe 2 properties of chlorine. How many groups are there in the periodic table? How many groups are there in the periodic table? So for this homework, grade 9s, you can get it on YouTube via this video, or you can go to www.africateengeeks.co.za and click under Natural Sciences, and you will get this. This brings us to the end of our lesson. Let us go back to my social media handles. There we go. For @MbataX, it's at Twitter, and Instagram is at XKIM. You can find me in those. You can find me MbataX on Twitter or at XKIM Instagram. Please direct message me. I will respond immediately. And please also suggest before 2 p.m. today what you'd like us to revise tomorrow. Thank you so much for joining me. Don't forget to follow us. You can follow us on the following links. If you want, for more information, you can contact us at Africa Teen Geeks or follow us on social media at Africa Teen Geeks, at Aziora, at BDE, Basic Department of Education South Africa, hashtag Sasol Foundation at Sasol SA, or you can hashtag us STEM Champions. I thank you, grade 9s. I'm out of here.